Okay, so here we're going to have a look at 2016 Maths Leaving Cert Higher Level Paper 2. So this is question 1 first of all. Now question 1 is fairly straightforward. It's just a matter of finding the equation of this line here. So what we're given actually a triangle A, B and C, ABC here. And we're asked to find the equation of a line through B which is perpendicular to C. So it's basically this line here, through B perpendicular to AC. Now it's really just finding the equation of a line. So the equation of a line is y minus y1 is equal to m into x minus x1. In order to use this formula here, we need a point and a slope. We have a point B going through the line, or the line is going through that point rather, and that's B is 5, 3. So 5 goes here, 3 goes here. We don't have the slope. In order to find the slope of this line here, we find the slope of the line perpendicular to it. The line perpendicular to it is AC. So to find the equation of AC, we use this formula here. I've written down A and C here. So put the values into this formula here and you get a slope of minus 2 over 3. So the slope of this line here is minus 2 over 3, which means the slope of this line here is 3 over 2. Turn it upside down, change the sign. Okay, so now we have the slope 3 over 2. Slope 3 over 2. Okay, so all we've got to do now is just manipulate this formula here, multiply across by 2. So multiply across by 2 here, we get 2y minus 6 is equal to 3 times x minus 5, and so on. You end up with the equation of this line here as 3x minus 2y minus 9 equal to 0. Okay, this is actually one of the altitudes of this triangle. So we're going to use that in the next part of this question. Now I've drawn another altitude here. If we extend the base, we take AB as the base, we extend this base on. Haven't done it very accurately here, but you use a ruler, you'll do it a lot more accurately. You'll end up going out here, drop a line through C perpendicular to that line. There's another altitude. From there to there is an altitude of the triangle, using AB as the base. Continue that altitude on, and we've continued this altitude on as well. They intersect at this point here. This point here is called the orthocenter of this triangle. It's outside the triangle, but this is the orthocenter. It looks like it has coordinates 7, 6, or somewhere around there. Not very accurate at this stage. But in part 2, we're asked to find the coordinates of the orthocenter. So the orthocenter is the intersection of two altitudes, or three altitudes of the triangle. I've drawn 2 of them. We only need to draw 2 of them. So what we need to do here is we have the equation of this line. Next thing we're going to do is find the equation of this line here, using exactly the same procedure, and do simultaneous equations to find the point of intersection of these two lines. That will give us our point of intersection here, which is the orthocenter. So let's do that. We need to find the equation of this line here. We already have the equation of this line. So let's find the equation of this line here. So in order to find the equation of this line here, this is the equation we use. We need a point. We have a point C. We need a slope. We don't have the slope of this line, but we can find the slope of this line by finding the slope of the line AB. We have A, we have B, stick it into this formula here. I've done that down here for you. You can pause the video if you like and just have a look. But that's A, that's B. Stick these values into your formula, you get a slope of minus 5. So the slope of this line here is minus 5, which means the slope of this line here is 1 over 5. Turn this upside down, flip it upside down and change the sign. Stick that into the equation y minus y1 is equal to m into x minus x1. This is it here. And you end up with an equation 0 is equal to x minus 5y plus 23. Now I'm going to put this equation and this equation together. I've done it over here. You can pause the video and have a look at this, but these are the two equations of my two altitudes. I've done simultaneous equations here, and I've found that they intersect at 7, 6. So this is my these are the coordinates of my orthocenter, 7, 6. So again, you can have a look at this. It goes down along here. I found y. I put y into one of the equations. I found x is 7 here. That's it really. That's question 1. Let's have a look at question 2. Question 2 is point x has coordinates -1, 6, so -1, 6 here. Slope of the line xc is 1 over 7. So the slope of this line here is 1 over 7, and xc goes through the center. C is the center. The coordinates of the center are -g minus f. Now, the first thing they ask you to do is find the equation of this line here. Very straightforward. They even give you the slope. So this is the equation of a line. Put in x here, -1, 6. Put that in here. Put the slope in, manipulate this here, and you get the equation of this line here, x minus 7y plus 43 equal to 0. That's it. Second part is, C is the center of the circle S of radius 5. So we have a circle here, radius 5. The line L here, this is the line L here, it has equation 3x plus 4y minus 21 equal to 0. We have to find the equation of a circle that satisfies these conditions here, okay? So, find the equation of one such circle, so that implies there's more than one. So there might be another one out here possibly. Okay, so let's do that. Now, how am I going to do that? Well, what I'm going to do, the equation of a circle is given by this formula here. X minus h to be squared plus y minus k to be squared is equal to r squared. So we know what r is. We know r is 5. So this side of our equation will be 25. However, we don't know the center. So all we got to do is find what g and f are. If we know what g and f are, we can stick them in here. And that will give us the equation of our circle. So, how are we going to do that? Again, I'm going to use simultaneous equations. So what I'm going to do is I'm going to take the equation of this line here, write it out. I've written it out here. I know it goes through the center, minus g minus f. So instead of x, I put in minus g. Instead of y, I put in minus f. And I've simplified it to give me this equation here. So this is equation number 1. Now I need another equation. The other equation I'm going to write out is the distance between this point and this line here. That's given by this equation, this formula here. This is in your maths tables. So let's do that. Now I'm going to work down the left hand side here. Ignore the right hand side here for the moment. So the equation I'm going to use is this equation here. So it's 3 times minus g. Remember, the x1 and y1 is the point I'm using, which is minus g minus f. It's this point here. So minus g goes in here, minus f goes in here. 4 is my b here, and minus 21 is my c. Square root of a squared plus b squared. Well, a is 3, b is 4. Square them, you get 9 and 16. All of this gives me 5. So simplify it here, minus 3g minus 4f minus 21 over 5. Multiply across by 5 here gives me 25 here. Now, what I could do from here on in, this is a modular equation here. I could square both sides, but what I've decided to do is do it the other way. I'm just going to write out minus 3g minus 4f minus 21 is equal to plus 25. Minus 3g minus 4f minus 21 is equal to minus 25. Now the question did say that there were going to be more than one circle equations that we could end up with. So, this indicates 2 anyway. So if I use this equation with this equation, it'll give me one set of values for f and g. If I use this equation and this equation here, it'll give me a different set of values for f and g. So I'm going to use this second one here. Now the first thing I'm going to do with this equation here is take that minus 21, bring it over here, or add 21 to both sides, so that'll give me minus 4. Okay, so I'm going to use that equation with this equation here, and that's what I've done on the right hand side here. So the first thing I've done is I've taken this equation, that was my straight line, and I've written it here. This is my equation here. I've written it out again. And I've just done simultaneous equations down here. Again, you can pause the video, just have a look at the calculations here. I've taken equation 1, multiplied it by minus 3, and so on, and so on, and so on. I've got f as minus 5, I've got g as 8. So f is minus 5 and g is 8. Now remember, our center is minus g minus f. So minus g is minus 8, minus f is plus 5. Stick those into the equation of a circle formula. So it's x plus 8 to be all squared plus y minus 5 to be squared is equal to 5 squared, or r squared, which is 25. That's the equation of one of our circles. If you use this equation here, you'd get a different set of values for f and g, and that will give you your other equation then. Okay, now let's look at question 3 here. Question 3 here is to show that cos 7a plus cos a over sin 7a minus sin a is equal to cot 3a. Now cot is just cos over sin. That's in your maths tables. Cot is just the inverse of tan. And remember, tan is sine over cos, so cot is cos over sine. Now I'm going to use these two particular trigonometric identities here that are in your maths tables. Cos a plus cos b is equal to 2, cos a plus b over 2, cos a minus b over 2, then sin a minus sin b is equal to 2, cos a plus b over 2, sin a minus b over 2. These are in your maths tables. So I've written them out here. We have cos 7a plus cos a. So that's 7a is my a, the a is b if you like. So that gives me 2 cos. I need to add the two values here, my two angles. So 7a plus a is 8a over 2. And then cos a, now I need to subtract them. So 7a minus a gives me 6a over 2. Same on the bottom using this. So we have 2 cos, add them. So 7a plus a is 8a over 2. Sine, subtract them. So that gives me 7a minus a, which is 6a over 2. So that gives me, these will divide, so 2 divided by 2 is 1. Cos 8a over 2, cos 8a over 2 will divide to give me 1. So I'm just left with 6a over 2, which is 3a, 6a over 2, which is 3a. Cos over sine is cot. Cos over sine is cot. So that's it. So fairly straightforward. Okay, part B here now. This is part B. Given that cos 2 theta is 1 over 9, find cos of theta in this form here. Plus or minus root a over b, where a over b are natural numbers. Now I've done it here. I've done it two different ways. So let's work down the left hand side first. I've used this identity here. This is in your maths tables as well. Cos squared theta is equal to a half 1 plus cos 2 theta. We know that cos 2 theta is 1 over 9, so I just took that in here. Multiply out the brackets. Half times 1 is a half. Half times 1/9 is 1 over 18. Add 1 half and 1/18. You get 10 over 18, which is 5/9. Get the square root of both sides. So the square root of both sides is plus. On the left hand side it's cos theta. The right hand side plus or minus root 5 over root 9, which is 3. That's it. We can use this identity as well, which more or less is the same kind of thing, but we start with cos squared theta minus sin squared theta is equal to cos 2 theta. Now we don't need sines, so let's change the sin squared theta to 1 minus cos squared theta. Take away that, we know that cos 2 theta is 1 over 9. Take away the brackets here, so that's minus 1, minus minus is plus here, cos squared theta. We have cos squared theta plus cos squared theta is 2 cos squared theta. Add 1 to both sides, so we're adding 1 here, and it disappears from this side. Divide by 2, so that gives me cos squared theta. So divide by 2 or multiply by a half here. So half times 1/9 is 1/18, half times 1 is half, and that just brings me back to here on the left hand side. So I'll just let you read through the rest yourself. That's the first 3 questions of paper 2.